Good afternoon to all of you. So welcome to this second live session for the course Fundamentals of Convective Heat Transfer. So if you have any questions, you please post here. And already we have received few questions in the Google form, so that also we'll discuss. So if you have any queries, you please post it here. So if you have any question, please post here. Okay, so we'll discuss those questions. PPT. So this is the question we received in the Google form. What is the difference between thermal boundary layer and temperature boundary layer? If they are same, please explain question 1 of assignment 6. Okay, in the question 1 of assignment 6, I have pasted here, you can see. Thermal boundary layer and temperature boundary layer are same. Okay, so you can see here here it is written thermal boundary layer, and here it is written temperature boundary layer. Okay, so as we tell velocity boundary layer, similarly we can tell also temperature boundary layer. So in this case, thermal boundary layer and temperature boundary layer are same. In question 2 of assignment 6, the temperature decreases exponentially with x, but again when we write heat transfer equation, there is a minus before t, so should not be answer be increases linearly with x. Although I didn't understand your second part of the question, but I will answer how this heat flux or heat transfer rate decreases exponentially with x, that I will show. So you can see this is the question 2 of assignment 6. In the thermally and hydrodynamically fully developed flow of a fluid, with constant properties in a circular duct, the wall heat flux, okay, so the answer will be decreases exponentially with x. So if you see that for a uniform wall temperature case, we have shown that Q double prime W, which is your heat flux, okay, H into TW minus Tm, and Tm, which is the mean temperature, and you know that it is a function of x. Okay. Now also we have derived that Tw minus Tm as Tw minus Tmi e to the power minus p h bar by m dot cp into x. So now if you substitute this here and if you write the wall heat flux Q double prime W as H into Tw minus Tmi e to the power minus ph bar by m dot cp into x. So here you can see for a fully developed case, H is constant, okay, that we have already shown, okay, and Tmi is the mean temperature at inlet, that is also constant, okay. So and in the exponential you can see that h bar is the average heat transfer coefficient ph bar by m dot cp into x. So obviously you can see that Q double prime W decreases exponentially with x, okay. So another question here, is the heat transfer from surface to fluid only convective heat transfer, or heat transfer from one point to another by means flow of fluid also convective heat transfer? For example, hot fog coming out of the chimney and it flows from chimney to another place so that heat is transferred. What kind of heat transfer is this? If it is convective heat transfer, according to Newton's law of cooling, we don't have any surface temperature. How can we accommodate this heat transfer? And what kind of law governs this situation? Please clarify and elaborate. So you can see that in this question, obviously when heat transfer is taking place from one point to another, that is obviously by convective heat transfer. And if you consider that if two fluid jets are coming, let us say you have a one fluid jet here, another fluid jet here, okay, and temperatures are different. Let us say its temperature is T1 and it is temperature T2. So these are two jets of two different liquids of different temperature, or same liquid with different temperature. Let us say same liquid with different temperature. Then obviously when it will flow, there will be a mixing and there will be a velocity profile like this, somewhat like this, okay. So there is no surface present here. So in this case, obviously you can see that temperature from the higher temperature fluid to heat transfer will take place from higher temperature fluid to the lower temperature fluid, and there will be heat transfer due to convection. But in this case we cannot find the heat flux, because heat flux mostly we are interested to find at the surface or wall. So as there are no surfaces here, so we can find that heat transfer rate Q, you can write just m dot cp into delta T, and delta T is the temperature difference, and at steady state you can find this is the heat transfer between these two fluids. And if you are interested to find the final temperature, then you can write Tf is equal to M1 C1 T1 plus M2 C2 T2 divided by M1 C1 plus M2 C2. And if you see that if you have same liquid of two jets of same liquid, then final temperature obviously will be T1 plus T2 divided by 2. From here you can see, because M1 C1 is equal to M2 C2. So you can find the final temperature like this, and you can calculate the heat transfer. Total heat transfer rate is m dot Cp delta T. Next, another question was there. Can you mention the question pattern for exam? So obviously you are solving these assignment questions every week, and the question pattern will be similar to the assignment questions. Okay. So there will be MCQ type questions and fill in the blanks type of question. So where you need to calculate something or value, then you need to put. Okay. So now I will take a few questions which actually already posted in this forum. So the answer of this assignment 6 will be released soon. Then you will be able to know what is the answer of this question 1 and of assignment, all questions of assignment 6. And today I think you have already seen that all the PPT files in PDF format are uploaded. Okay. So you can check, log in into the NPTEL forum. So if you have any other questions, you please post it here. Already I have discussed the questions which were posted in the Google form. Say answers are correct. Okay, whatever questions were asked in assignment 6, the questions already those are correct. So there are no ambiguities in the questions, and whatever the correct answer is, accordingly this will be graded. Okay. The answer of question 1 of assignment 6, I think the last option means all three options are correct. Okay. Say Newton's law of cooling, where we apply. Say you have a surface at any temperature, then we write the heat transfer rate Q is equal to H into A into TW minus T infinity for the external flows, and TW minus Tm, where Tm is the bulk mean temperature in internal flows. So you can see surface must be present in this case, okay, while calculating the heat flux or heat transfer rate from this expression. Okay, so I will recheck the question what was posted, question number 1 of assignment 6, and if there are some mistakes or ambiguity, then accordingly the marks will be given. Say heat flux in general we have defined. Okay, so heat flux is a vector quantity, whether it is heat flux by conduction or convection or radiation, because it occurs from the surface, and heat flux always we measure perpendicular to the surface. Okay, for that reason heat flux is a vector quantity. Okay, so if you have a curved surface at different places, your normal will change. Okay, and heat flux will define based on the normal to that surface. Okay, so for that reason heat flux is a vector quantity. Heat flux, say by definition, when you are actually using, let us say, conduction, then heat flux is just minus k del T by del X, right? And del T by del X is a gradient, and that in the X direction you are calculating for the one-dimensional heat conduction. Now, if you consider curved surface, okay, there will be a normal direction. Uh, just I will draw in this PPT. Can you please open this PPT? So you can see that when we considered one-dimensional, let us say here heat transfer is taking place, and uh, uh, if you consider the heat conduction from here, okay, so if this is the X, then always we write that q double prime x is equal to minus k del T by del X. Okay, so now if you have a curved surface, and let us say this is the normal, now you have x, y, let us say two-dimensional case, so x and y. So now in this case your q double prime n is minus k del T by del L. Okay, so this is the uh, heat transfer is taking place normal to the surface. Now if you want to take two components, then you can find from here two components in the x direction and y direction. Okay, but the heat flux is normal, always normal to the surface, and we will calculate q double prime n is equal to minus k del T by del n, where n is the normal to this surface. Okay, and you can have two components in the x and y direction, and that's why it is actually a vector quantity. Now if you want to calculate the heat transfer rate, so this is heat flux. Now if you want to calculate the heat transfer rate, now you are actually multiplying with the area. So if you have the elemental area here, say q n dn, then obviously it will become a scalar quantity. Okay. Okay, so I think you have understood here. Okay, so heat flux always is a vector quantity. So by definition of Fourier's law, what way this is derived, so that is perpendicular to the surface. Okay, so always you start learning the heat conduction for a one-dimensional case, and if you take X, so always it is perpendicular direction. Okay, so heat is going out perpendicular to the surface. And if you multiply with the area, so this area you can see it is normal to that area. The normal means the area normal vector will be the normal to this area. Obviously, then when you are multiplying with the area, you are not taking any components or x and y. If it is a curved surface, the area in x direction and area in y direction will be different, right? But when you are considering the actual surface area, then that will be just normal to that surface. Say different. You are talking about this question, I guess. Why do you always quantify the heat transfer as heat flux rather than heat rate in watts? So you can see that heat transfer rate we just rate. So it is obviously it is joule per second. So it is in watt. And different books you can see that they follow different terminology. So you have seen that when I taught in this course, I always I was consistent in telling heat transfer rate or heat flux. Okay, so heat transfer rate in watts and watt per meter square is heat flux. And if you are talking, so these are different books follow different terminology. So obviously heat transfer, maybe it is written as heat flux or heat rate. So rate is there, so you can see that you can heat transfer rate or heat rate. Okay, so that is actually denoted in watts. So here in first live session, I discuss about this, that this is a PG level course, advanced level heat transfer course. So one should have credited the basic heat transfer course, where you learn fundamentals of conduction, radiation, as well as convection. But this is a pure course on convective heat transfer. So obviously it is more analytical and in-depth study. We have already seen that we have done rigorous derivation in this course. So obviously it will be somewhat difficult, but as it is a PG level course, or final year BTech student can take as a as an elective. Okay. Say, when you are talking about heat flux and heat transfer rate, what are the differences? Say, when you are considering heat flux, so heat flux we are actually at a particular point you can calculate. Okay, and now say heat flux may vary along the axial direction. Let us say you have a flat surface and horizontal flat surface, and coordinate x is in that direction. Then obviously, say if you are maintaining constant wall temperature, then we have seen that heat flux will vary along the x. Okay. Now it is very difficult to denote the heat transfer rate at every point, right? Heat transfer rate we generally talk about when for the whole surface. So we know the whole surface area, we know at each point what is the heat flux, then we integrate over the surface, then we get the heat transfer rate. So when we are interested to know the total heat transfer rate from a wall or from a tube, then obviously you have to uh, denote, or you have to express in terms of heat transfer rate. But as heat flux varies along x, so obviously at each point you cannot denote with the heat transfer rate. So that's why heat flux is more convenient to express at any point. Okay. So heat flux is always a vector quantity, and heat flux we are denoting at the wall. Okay, and here you are talking about a mixing of fluids. So at a mixing of fluids, you are not considering any surface, right? Then we are not discussing about heat flux. I told whatever expression I have written, that is the heat transfer rate. Okay, and that is at steady state. Okay, so obviously in this case, when we considered these two uh, uh, jets of different temperature, there it is not easy to find the heat transfer rate, because it will vary, okay, along the axial direction. Whatever I have given the expression, so if you have two bulk liquids of different temperature, if you mix and at steady state, that will be the heat transfer rate. Okay, but whatever problem I discussed, that two jets of different liquid or same liquid, so now means it will be difficult to find the heat transfer rate in that case. Okay, we are not telling about the heat flux. So in space, is all the heat transferred only due to radiation? So now there are different space stations also, right? So there are surfaces. So obviously, means in a near region of this spacecraft, obviously conduction may take place. Otherwise, it will be only due to radiation. So if you don't have any further questions, okay, we'll end the session. So let us wait for another 1 minute. Otherwise, we'll end the session. So the ambiguity in the question 1 of assignment 6, I will look into it, and uh, if there are ambiguity in the questions, the marks will be adjusted accordingly. And if you have any further questions, you please post it in the discussion forum. We will answer. And again, we'll meet in the third live session. Thank you.